In the previous lecture, we have learned first law of thermodynamics, and the mathematical form of first law of thermodynamics is dq equal to du plus minus dw equal to du plus p dv, as dw is equal to minus p dv. This is the first law of thermodynamics, and also we have learned for adiabatic process pv to the power gamma is equal to constant, and pv is equal to RT, which is true for ideal case. Now, as you know, gamma is equal to Cp by Cv. And gamma, it can also be represented as 1 plus 2 by f, where f is the degrees of freedom. Gamma equal to Cp by Cv, the ratio of heat at constant pressure and at constant volume, equal to 1 plus 2 by f, where f is the degrees of freedom. Now, what is degrees of freedom? F equal to 3n minus k. N is the number of molecules and k is the n is the number of molecules and k is the constraint. Suppose we have a diatomic molecule. So, oxygen is a diatomic molecule. So, there must be a bonding between O and O, and this is forming oxygen molecule. So, here F is equal to 3 into 2, as the number of molecules is 2 and number of constant is distance. Constant means the distance between the atoms O and O is fixed. So, here the constant is 1. So, number of degrees of freedom 5. For monoatomic molecule, suppose helium, F is equal to 3 into 1 minus 0, because there is no bonding for monoatomic molecules, and number of degrees of freedom would be 3. For triatomic molecules, the structure may be like this, as for example ozone, or the structure may be like this. Okay. This is for carbon dioxide molecule, C oxygen, oxygen, and this is for ozone. Now, so for triatomic molecule, F is equal to 3 into 3 minus, for this arrangement the number of constant is 3, so number of 10 degrees of freedom 6, and for this arrangement F is equal to 3 into 3, number of constant is 2, is equal to 7. So, for a monoatomic molecule, gamma is equal to 1 plus 2 by f. For monoatomic molecule, gamma is equal to what will happen? Cp by Cv, 1 plus 2 by f, that means 1 plus 2 by 3, that means 5 by 3. For diatomic molecules, gamma is equal to 1 plus 2 by 5, that means 7 by 5. And for triatomic molecules, gamma either becomes 1 plus 2 by 6, that means 8 by 6, 4 by 3, or gamma is equal to 1 plus 2 by 7, 9 by 7. This is the value of gamma. And you know Cp minus Cv is equal to R, and from this we can determine Cv is equal to 3 by 2R for monoatomic molecules, 5 by 2R for diatomic molecules, and Cp is equal to 5 by 2R for monoatomic molecules and 7 by 2R for diatomic molecules. You have to remember these portions. So, for diatomic molecule you have to remember Cv is equal to 3 by 2R for monoatomic molecule, for diatomic molecule it is 5 by 2R, and Cp is equal to 5 by 2R for monoatomic molecules and 7 by 2R for diatomic molecules. So, you have to remember this value of Cp and Cv for the examination purpose. Now, suppose we are doing the experiment in isochoric process. So, in isochoric process volume remains constant for isochoric. So, we are doing the experiment for isochoric process, that means V is equal to constant. The V is equal to constant, so dq is equal to du plus p dv. Volume constant, this means that this term is 0. So, dq is equal to du. Again we know du is equal to Cv d theta. Again we can write Cv is equal to Cv d theta P2 V by R minus P1 V by R. I am repeating, for isochoric process this term vanishes, so it becomes du, and du equal to Cv d theta for ideal gas. So, d theta, as you know Pv is equal to constant, that means RT. So, V is equal to T is equal to Pv by R. So, either you can write is Cv theta 2 minus theta 1, but if theta 2 and theta 1 are not given, pressure and volume given, then the equation becomes Cv P2 V by R minus P1 V by R, as T is equal to T of theta equal to Pv by R. So, which form you will be needed for the examination purpose, you have to remember all these mathematical tools. Suppose we are doing the experiment and we get the PV curve like this. We are going from A to B, and data only given, it is performed at 400 Kelvin and it is experiment is performed in 800 Kelvin. So, if the question comes for 1 mole of diatomic gas, find the change in internal energy. The experiment is performed for diatomic gas and 1 mole. So, you have to calculate the change in internal energy. So, change in internal energy means du means Cv d theta. For diatomic molecules, Cv equal to 5 by 2r and theta 2 minus theta 1. That means 5 by 2r 800 minus 400. That means 1000 R. Now, suppose the graph PV graph is like this, the same, it is given the twice P0 and it is P0. And this is P0, A, P again. This is the same graph, but here data is given not in temperature. For going from A to B, the pressure is changing from P0 to P0 and both are isochoric process, and the experiment is performed at the constant volume P0. Again you have to calculate the change in internal energy. Suppose we have to calculate the temperature Ta. Suppose we have the temperature Tb at the point A and B. So, we can write the equation P0 V0 by Ta is equal to twice P0 V0 by Tb, as Pv by T always remain constant. And from this we get Tb is equal to twice Ta. So, temperature at P point is twice the temperature at A point, and for this reason pressure is changing from P0 to twice P0. So, du is equal to Cv Tb minus Ta, and it is for diatomic gas. So, 5 by 2r Tb minus Ta, that means twice Ta minus Ta, that means 5 by 2r Ta. This is in terms of temperature, but here the Ta is not given. So, we will write the equation 5 by 2r P0 V0